Welcome back, everybody. Let's define variance. The variance of x is the expectation of x minus mu squared, where mu is the mean or the expectation of x. So what is this? Well, so this expectation of x minus mu squared, what is that? Well, that is the average squared distance from x to mu. So in other words, variance of x tells us how far away the value of x is from its mean on the average. And it's easy to show that the expectation of x minus mu squared is equal to the expectation of x squared minus the square of the expectation of x. Now again, expectation of x is the same as the mu or the mean. So oftentimes we use this formula to compute the variance instead of directly computing the expectation of x minus mu squared. Here's the fact that the variance of ax plus b is equal to a squared times the variance of x. So here's an example. Let's say we have a variable x with PDF given by f of x, which is equal to 2x if x is between 0 and 1 and it's 0 otherwise. So what's the variance of x? Well, the variance of x is the expected value of x squared minus the expected value of x whole squared. Now we'll show that the expected value of x squared is half and the expectation of x is 2/3, so you square that and then whatever you get out of that. Now what is the expected value of x? Well, that's the integral from 0 to 1 of x times the PDF. The PDF is 2x dx. Now we're going from so by definition we should be going from negative infinity to positive infinity, but then we're going from 0 to 1 because the PDF is 0 outside of this range. And then we get the integral from 0 to 1 of 2x squared dx, and then that's equal to 2/3. The expectation of x squared, on the other hand, would be the integral from 0 to 1 of x squared times the PDF 2x dx, and that's the integral from 0 to 1 of 2x cubed dx, which is equal to half at the end. So the variance turns out to be half minus 2/3 squared. Okay, so that's the end of my discussion on variance, and in the videos that's coming we'll be starting to look at certain kinds of distributions.